Okay, we are practicing our basic trig word problems now. So on our word problems, let's start out with a few basic steps. As always, we want to remind ourselves that we have so what? Ka. Toa. Okay, so the first step is, if we know that we're dealing with basic trig word problems, we're going to draw a right triangle. Make sure you have appropriate behavior. So for problem number 1, let's go ahead and draw a right triangle. It doesn't matter what direction you draw it, just draw a right triangle. The next step is to label the triangle based on the problem. So let's read problem number 1. It says, a boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? So we need to label on our triangle. We have the ground. We want to know how high above the ground. And we know that we have kite string. Now, on our picture, let's think through this. Which side of our triangle will be the ground? Which side will be the ground? Well, think about where the ground is. The ground is going to be down here. Okay, assuming that the string makes an angle of 38 degrees with the ground. We know that this is the right angle, so it can't be 38 degrees. We have to have 38 degrees with the ground. So the only other place we could put the 38 degrees for it to be with the ground would be over here. So that we know we have our little guy over here with his kite. If this is the ground, then this side has to be the what? The kite string. Okay, so let's label, a boy is flying a kite and he lets out 300 feet of string. So we have 300 feet here. That makes an angle of 38 degrees with the ground. We know we have our 38 degrees there. Assuming that the string is straight, we have a straight line for our string. So our kite's over here. Please stop popping your gum. It's obnoxious. We want to know how high above the ground is the kite.
Let me get that. Hey, baby. Portal.
Now, we want to know how high, so let's label this height above ground. So we've now labeled our triangle based on the problem. Now we need to determine the trig function. So we're going to shade like we have been shading. So if we shade the two sides of our right angle, we know that what side is our hypotenuse? The 300 feet, the kite string, is our hypotenuse. Okay, if we shade the two sides of the 38-degree angle, which side is our opposite? X. That means the ground is our adjacent. Okay, we had information about our opposite and our hypotenuse. So what function does that make? Everyone. Sine. So we know, for reference, I'm going to write this out. We know that the sine of an angle is equal to O over H. So we know that the sine of 38 degrees is equal to, what is my opposite?
X.
X. What is my hypotenuse? 300. Now my last step is to solve. So the easiest way to solve this is to set up a what? Proportion. I can put anything over what? 1. How do I solve a proportion? Cross multiply. So I know that 1 times x is x. So x equals 300 times the sine of 38 degrees. That's exact. I expect to see this step on your paper. So x is approximately, and on this paper, I want you to round to the nearest tenth. So let's put that. So when you punch that in your calculator, 300 times the sine of 38 degrees make sure you are in degree mode. What do you get? You get approximately 184.7. What are our units? What units are we using for this problem? Feet. You have to answer the problem in question. You have to answer the problem in question. Third. Okay, for problem number 2, we're going to follow the same steps. So first of all, we need to draw a right triangle. Like I said before, it's not about the direction that you draw the right triangle in. You just have to draw a right triangle to start out with. Okay, we're going to label the triangle based on the problem. So it says, a ladder leaning against the wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? That means we know we have a ladder. We have a wall, very good. And we also have the ground. So let's label our sides. Which one's going to be the ground? The bottom. Which one's going to be the wall? Is the wall going to be the one that's going straight up, or is it going to be the diagonal one? The wall is going to be straight up, and that means the diagonal one is going to be the ladder. Okay, a ladder is leaning against the wall, makes an angle of 74 degrees with the ground. So the ladder and the ground have a 74-degree angle between them. If the foot of the ladder is 6.5 feet from the wall, the foot of the ladder is 6.5 feet from the wall. So which side is 6.5 feet? Which one? The bottom, the ground. The foot of the ladder is down here. The foot of the ladder is 6.5 feet from the wall. So 6.5 feet. Read the problem carefully. How high on the wall is the ladder? So which side are we trying to find?
The hypotenuse.
Are we trying to find the ladder or the wall? It says how high on the wall?
The wall. Oh.
The wall. We're trying to find the wall. So now let's determine the trig function. So which side is my hypotenuse? The ladder is my hypotenuse. Which side, Alexis, is my opposite? X, the wall, is my opposite. And that means the ground is my adjacent. Very good. Okay, I have my opposite and my adjacent with information about them. Opposite and adjacent make which trig function? Opposite and adjacent make tangent. So we have the tangent of an angle, we're just going to remind ourselves, is opposite over adjacent. So we have the tangent of 74 degrees is equal to, what is my opposite? X. Very good. What is my adjacent? 6.5. The easiest way to solve this is to set up a proportion. The easiest way to solve a proportion is to cross multiply. So I have x times 1, which is just x, is equal to exactly 6.5 times the tangent of 74 degrees. You're going to punch that in your calculator. Again, on this whole paper, I want you to round to the nearest tenth. and tell me what you get. Does everyone agree that it's 22.7? Yes. Approximately 22.7 what? Feet. Approximately 22.7 feet. Okay, we are going to continue on to problem number 3. The first thing we need to do is to draw a right triangle. Now we need to label the triangle based on the problem. A straight road to the top of a hill is 2,500 feet long and makes an angle of 12 degrees with the horizontal. Find the height of the hill. Okay, so we know that we have a road. We have the horizontal. And we have a hill. Okay, which side is the horizontal? Horizontal, think of the horizon. Horizontal has to go horizontal. This is the horizontal direction. Okay, we need to draw the hill. So I'm going to sketch in. Your hill's probably like this. So which side is the height of the hill? Which side's going to be the height of my hill? Well, if my hill's over here, this is going to be the height of my hill. That means the other side has to be my what? Road, which makes sense because the road is going up to the top of the hill. Okay, a straight road to the top of a hill is how long? 2,500 feet. And it makes an angle of 12 degrees with the horizontal. So we need to label 12 degrees with the horizontal. So we've now labeled our triangle. We have to determine next the trig function. So which side is my hypotenuse? The road is my hypotenuse. Which side is my opposite? The height of my hill is my opposite. And that means the horizontal is my adjacent. Now, let's go back. Sometimes you miss something. We're going to go back to the problem. What were we trying to find? We were trying to find the height of the hill. So the height of the hill is our variable, so that's our x. So that means we have information about, close the door please. We have information about what two sides? O and H, which makes sine. So the sine of an angle is what or what? O over H. So the sine of 12 degrees is equal to, what is my opposite? X. What is my hypotenuse? 2,500. The easiest way to do this is to set up a proportion. What do I need to do next? How do I solve a proportion? Cross multiply. So x, 1 times x is x. Austin, what do I have on the other side of my equation? I did 1 times x. I have to do what else? 2,500 times the sine of 12 degrees. So x is approximately, and again, nearest 10th. These are my directions. These are my directions. So when you punch that in your calculator, what do you get rounded to the nearest 10th? Approximately 519 point what? 8 what? Feet. Approximately 519.8 feet. Okay, today we're going to start with basic trig word problems. So let's go ahead and write a few notes at the top. Let's remind ourselves, like always, that we have so what?
Sokatoa.
Very good. Sokatoa. Now in this class, we're actually going to start on the problems on the back first. So I'm going to fold my paper over so that you can see the notes along with problem number 7 at the same time. So I'm just explaining what I'm doing here. Okay. The first step that we're going to do is to draw a right triangle. It doesn't matter what direction you draw a right triangle. You just have to draw a right triangle. So for problem number 7, you need to draw in a right triangle. The next step is we're going to label the triangle based on the problem. So how do we label the triangle based on the problem? Well, it means that we're going to have to read the problem thoroughly and pick out what information we need. So in this problem, it says, a 25-foot ladder leans against a building. The ladder's base is 13.5 feet from the building. Find the angle which the ladder makes with the ground. Okay, so let's identify some important information in our problem. We know that we have a ladder. What else do we have?
A triangle.
A building. And the ground. Okay, which side is going to be the ground? The bottom. We don't know if it's the opposite yet. We haven't labeled our angles yet. We just know that it's the bottom, it's the ground. Okay, which side is the building?
The triangle.
The vertical side. A building is vertical, so we know that this is our building. And our diagonal side is the what?
Ladder.
The ladder. Okay, let's keep labeling. It says we have a 25-foot ladder. So we need to label that we have 25 feet for the ladder. It leans against a building. The ladder's base is 13.5 feet from the building. So let's identify that in the picture. The base of the triangle, the base of the ladder is 13.5 feet from the building. So the base of the ladder is down here. So which side is 13.5 feet? The ground. The bottom of the ladder, so it's the ladder over here. Climb the ladder. The bottom of the ladder is 13.5 feet from the building. You want to draw in your building, put in some windows, put in a door.
Small building.
All right. Now, we want to find the angle which the ladder makes with the ground. So ladder and ground. We want to know the angle here. So that's question mark. Okay, next we're going to determine the trig function. So we need to identify our sides. So if I highlight the two sides of the right angle, I know that the hypotenuse is how much? 25 feet. The hypotenuse is my ladder. Okay, I'm going to highlight the two sides of the angle in question. The angle of the ladder to the ground. So that tells me that the building is the opposite, which means the ground has to be the adjacent. Very good. Now I'm going to identify which trig function this makes. So let's take a look. We have adjacent and hypotenuse. Adjacent and hypotenuse make what? Cosine. We're trying to find an angle. So we're not going to use regular cosine. We're going to use inverse cosine. Good. So the inverse cosine of A over H is equal to the angle. So is my A? 13.5. What is my H? 25 feet. Okay, I want you to go to the nearest degree. So punch this in your calculator. Remember, on your calculator, you must use the inverse cosine. It must be the inverse cosine. We do 13.5 divided by 25. We get 57.3. 0.3 rounds down, so it's approximately 57 degrees. Approximately 57 degrees. Okay, when we're dealing with trig word problems, we know that the first thing that we need to do is to draw a right triangle. Like I said before, it really doesn't matter how you draw the right triangle. You just need to draw a right triangle so that you can label. Next, we need to label the triangle based on the problem itself. So this problem says, in order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet straight up a road which leads to the top. Find the number of degrees contained in the angle which the road makes with the horizontal. I think this word confuses the problem a slight bit, so let's scratch out the word straight. Okay, we know that we have to reach the top of a hill. The hill is 250 feet high. You must travel 2,000 feet on a road. And we want to find the number of degrees contained in the angle which the road makes with the horizontal. So we also have the horizontal. Okay, which side is going to be the horizontal?
The bottom.
The bottom, the only side that actually is horizontal. Okay, let's draw in a little hill. I'm just going to sketch in a little hill. So that tells me that which side represents my hill? The height of my hill. So it says the top of the hill is 250 feet high. So which side is going to represent the height of my hill? The vertical side. It's going to the top of the hill. That means which side is going to be my road? The diagonal. And when you finish labeling, go back and make sure it makes sense. It doesn't make sense to climb straight up a road. When it's saying straight up, it just means that it's not a windy road. Okay? So you can't just go straight up. That would be flying. That would be a rocket. So your road has to make it up to the top of the hill. Okay, your hill is 250 feet. You must travel 2,000 feet along the road. And we want to know the number of degrees contained in the angle which the road makes with the horizontal. So road and horizontal, we want to know the number of degrees of this angle. So now we need to label. If I shade the two sides of my hypotenuse, I find out, the two sides of my right angle, I find that the hypotenuse is the road. If I shade the two sides of my angle in question, I find that the opposite is the hill. That means the horizontal is my adjacent. I have information about my opposite and my hypotenuse. Opposite and hypotenuse make sine, but I'm trying to find the angle. So I'm going to use inverse sine. So I put in my O over H. I'm going to get out my angle. What is my opposite? 250 feet. What is my hypotenuse? 2,000 feet. We're going to do nearest degree again. So approximately. So the inverse sine of 250 divided by 2,000 equals approximately 7 degrees. Approximately 7 degrees. Record. Okay, so for problem number 9, it says a ladder leans against a building. The top of the ladder reaches a point on the building, which is 18 feet above the ground. The foot of the ladder is 7 feet from the building. Find the measure of the angle which the ladder makes with the level ground. Okay, so the first thing we need to do is to draw our right triangle. Now we need to label, step 2, we need to label our triangle based on the problem. So the first thing we're going to do is pick out the information in our problem to label the sides. So what types of things do we have that we need to label on the sides? We have a building. We have, what else? The ground. And we have a ladder. Okay, let's think through this. The ground has to be where?
The bottom.
At the bottom. It has to be level. So this is the ground. Okay. The building. What does a building look like? Where does the building have to be? It has to be vertical. So we've got our building. You can draw a little building if you like. Okay, so we have our building. We need to label our building. That means our ladder is what side of the triangle? The hypotenuse. Okay, let's go back and reread. A ladder leans against a building. The top of the ladder, I need your full attention. The top of the ladder reaches a point on the building, which is 18 feet above the ground. So we know we have 18 feet. The foot of the ladder is 7 feet from the building. Find the measure of the angle which the ladder makes with the level ground. Then we need to label. Which side is 18 feet? The top of the ladder, so the top of the ladder reaches a point on the building which is 18 feet above the ground. So we're going 18 feet above the ground. So we know that we have 18 feet on the building side. The foot of the ladder is 7 feet from the building. The foot of the ladder, so which side is 7 feet? The ground. Very good. Now, we need to find the measure of the angle which the ladder makes with the level ground. So the ladder with the ground, we want to know what angle it makes. As always, please raise your hand if you have a question. So we need to know what angle the ladder makes with the level ground. We're still labeling our triangle based on the problem. So if I highlight the two sides of the right angle, I find that the ladder is my hypotenuse. Very good. If I shade the two sides of the angle that I care about, so the angle of the ladder with the ground, I find that the building is my opposite. I have information about that side, so I circled it. And that means the ground is my adjacent. I have information about that side, so I circled it. So now I need to determine my trig function. I have opposite and adjacent, which makes what? Tangent. But I'm trying to find an angle. So I'm not going to use regular tangent. What am I going to use? Inverse tangent. So we know that the inverse tangent of opposite over adjacent gives me the angle. So I'm going to say the inverse tangent. What is my opposite? 18. What is my adjacent? 7. Now all I have to do is punch this in my calculator. I do have to make sure that I'm in degree mode as always. Make sure you use inverse tangent. So second tangent, make sure it's inverse tangent. 18 divided by 7. For the angles, for the angle problems, we're going to round to the nearest degree. So a whole number on the angles, unless otherwise noted. Angles, round to the nearest degree. Sides, round to the nearest tenth, unless otherwise noted. So if we are rounding this to the nearest degree, 68.7 would round to how many degrees? Approximately 69 degrees. So the ladder makes an angle of approximately 69 degrees with the ground.